So anyone know? What side of the battery? Positive, okay. And do we all agree with that? Because Jorge said negative in the positive terminal. Do we all agree? Yes? No? I don't know. Again, you just have to write yes or like something in the chat. Yes, okay, great. All right, and that's basically because Na is basically positive, so you want to do the opposite, which is when you go to the negative side. Cl is negative, which is when you go to the positive side. Pretty simple, pretty easy. Again, it's just electrolytes knowledge. And then what's an electrolyte? Think about Gatorade. Remember they always say, oh, there's like a bunch of electrolytes. What is that? What's an electrolyte? Can anyone tell me what is electrolyte? Again, think about the Gatorade. And they're like, oh, there's like 50 electrolytes in here. Even though there's like 50 grams of sugar in it, we're just going to ignore that. What about the electrolytes? What is that? It gives power? Yes, what's that power though? What's that called? Yeah, it does give you energy. It does give you that power called. Right? Because if you write on an exam like, oh, it gives you power, no one's going to know what you're talking about. Like, what do you mean power? Like energy? Like, what are you talking about? What is it? What's an electrolyte? Like in Gatorade, they say, oh, there's a bunch of electrolytes. What's the electrolyte? What is that called? What is it? If you don't know, like, you can just give me your best guess. Or like Stephanie give a pretty good guess. Or you can just like, just write, I don't know if you don't charged. Yeah. So it's like charged power. More specifically, I'll say, because you guys are on the right page, it's basically like, it's a solute that produces ions. That's the word I'm looking for. It produces ions. That's the charged energy or the charged power. It's a solute that produces ions, and what this does is it creates electronegativity. You guys remember that from exam 2? Mm-hmm. It's coming back. It all comes back eventually. Like it just circles and circles around each other. So electrolyte produces ions that conduct electronegativity. That's pretty much it. That's what Gatorade does. It just produces these ions that give you energy. That's why like a bunch of athletes drink Gatorade and stuff. So next one. What's the difference between a strong and regular electrolyte? Right? Because you have regular electrolytes like in your body and whatnot. But then you have strong electrolytes. Like people who take, pills and do all this stuff. Like what's the difference? What's a strong electrolyte? What is that? Versus a weak one or like a regular one. What's the difference? What does a strong electrolyte do that a regular one can't? Why would that be better for you? This is almost like physical education. What does strong electrolytes do for your body? Because you know it's good, right? But what does it do? Stronger electron in charges, stronger dissolve. Okay, yes, okay. So Akash, but the full answer is definitely what Jorge said. They fully dissolve in water. That's what you want. You want something when it's strong, it fully dissolves. Versus a weak electrolyte. What's the difference? What does a weak electrolyte do? Does it not dissolve at all? Does it completely dissolve? What is it? The strong completely dissolves, right? Completely dissolves. What does a weak electrolyte do? Does it not dissolve at all? What does it do? Does anyone have an answer? If strong is completely, somewhat dissolves. Okay. What do you mean somewhat? Like, somewhat dissolves. Like, sometimes it completely dissolves, sometimes it doesn't, like, dissolve all the way. Like, what do you mean? Not all. Yes, and do we agree with this? Yes, no, I don't know. Just someone else's input as well. Like, you can, again, like, if you know. Anyone else? Again, if you don't know, just write yes, no, I don't know. Yes, okay, great. Yeah, that's correct. So the word I'm looking for specifically is partially. It's partially ionized. Partially ionized. That's what you want. Partially. I can't really write on the computer, but partially ionized. So yeah, so I don't want anyone to get the idea that, oh, a weak electrolyte, it doesn't do anything at all, or it dissolves all the way. It's just partially. It's only half usually, or like a little bit. It's not all of it. It's not none of it. It's just in the middle. It's just kind of mediocre, if I'm being honest. That's pretty much it. It's not all or nothing. So this is pretty easy, right? It's just a warm-up. So let's keep going. And then these are the answers. So just how you know what that is, this section's pretty easy. So this question, the conductivity test of figure 8, you don't even know that. 8.9, you don't have to care about that, is carried out with 3 new solutions. 0.1 molar CH3OH, which is ethanol, 0.1 molar HF, and 0.1 molar LiF. The light bulb glows brightly when immersed in the 0.1 molar LiF solution. So brightly. there's a faint one in the 0.1 HF solution, and it doesn't glow at all in the CH3OH solution. Your job is to classify each of the three solutions as a strong electrolyte or a non-electrolyte. So let's do that first. Which is strong, which one's not? We have LiF, HF, and CH3OH. So what are the strong ones? What do you guys think? Which one's the strong one? Can anyone tell me? Which of these three is strong, like a strong electrolyte? Oh wait, and then somebody said, so regular is different from the weak. Yeah, regular is different from the weak one. Weak one is, it partially ionizes. And then LiF. Okay, why LiF? Why not HF? Why is it LiF? What makes it? Why is that strong? Why is CH3 not strong? Right? Why? Why is that? Can anyone write an explanation or like say on their mic, like, why is it? Why is it LiF? Does anyone know? What about it makes it so strong? Right? Why can't HF be strong? Why is that? Can anyone tell me? Like, how do you know it's LiF? Any answers? Any guesses? Does anyone know the answer? Yes, no, I don't know. You don't know? Okay. So the only information you're getting, I know this is like a huge paragraph, so you're like, oh, it's so much information, but it's really not. All it's saying is basically one is really bright, one is faint, and one doesn't glow at all, pretty much. So with this, there's a pattern. When you see this, there's a pattern. There's one specific pattern. And it's that the brighter it is, the more powerful, right? Because it's the number of ions that are present, so the power increases. So LiF, because it glows brightly, it has the most power, which means it's the strongest electrolyte. And then what about the second? Is it HF or CH3OH? Which one is the second strongest? Or what is the rest of them? What is HF? Does anyone know? Can anyone tell me what that is? What's HF? If LiF is a strong electrolyte, what's HF? Can anyone tell me what is that? What's that going to be? Does anyone know? HF. HF, weak. Okay, weak. Yes, correct, very nice. And we know it's weak because it just remains as, it just faints. It's very faint, it doesn't do much. Like if you're in a room and you have a weak light bulb, it's useless. Like it does almost nothing for you, right? Like why would anyone want a weak light bulb? We might as well have no light bulb, like that doesn't do anything. So it just remains as an HF molecule. LiF, it goes out as just Li, right? And that's the cation that you have. So it breaks up. HF just stays as HF. There's nothing that's happening to it. And then what about CH3OH? What does that end up being? Is that strong electrolyte? Weak? Like what is that? Non. Okay. And then what does everyone else think? Because Jorge said non-electrolyte. So if that's non-electrolyte, do we all agree? Is someone saying, oh, that's a strong one or that's weak? Or what do we think? Any other answers, guesses? If you don't know, please tell me if you don't know, because I'd rather have you not know now versus on the test and you're like, oh, I don't know the answer, you know, because the second attempts don't really help. So, do we all agree?
I don't know.
You don't know? Okay. So CH3OH is also a non-electrolyte. And the reason for that is that there's no dissociation. It also does not glow at all. That's your big hint right there. So it says that this solution doesn't glow, which means there's no power. There's no power, there's no electrolytes, non-electrolyte. There's no power there, right? It doesn't glow at all. There's no point in having it there, right? So that's why that would be non-electrolyte. And by the way, when you guys say weak for HF, I want to make it clear that it's a weak acid also. It's not just weak electrolyte, weak acid. So, do we agree with that? Do we all understand this? It's just the brightness. So the stronger it is. Yeah, basically for this one, because that's all the information they give you. It's a conductivity test, right? So that's the only way you would measure how strong it is. That's pretty much it. Is that okay? Oh, yeah. Yeah, conductivity test, yeah. So it looks like a big paragraph, but it's pretty easy. It's not bad. Okay, yep. This is the answers, and then LiF, you see the strongest, HF, and then CH3OH. So it's pretty easy, I think. And then we can keep going. So as a molecule, and then you're using this with this equation. So looking at this equation, if a molecule of HCl dissolves, it donates a blank to water molecules. Right? You see water molecules, HCl. What does it donate? Can anyone tell me? Like in this equation, CHL plus H2O, H. Okay, H. Okay, and what is that? What is that specifically? What would be H? Because you're on the right track, but not exactly. What is H? Because you're saying H, and I'm not saying you're wrong, but what is that called? Like if someone had choices and they didn't say specifically the element, what would you use in place of that? Not H, but something else. A. What is that called? The H in this equation. In an overall ionic equation like this, an acid. Okay. All right. Base. Okay. So, okay, you guys, not exactly. You guys are like on the right track of what you're donating. Ions, very close to. Okay, I'm just gonna say it because you guys are doing really, really well. But it's actually a proton I'm looking for. It donates a proton. That's the word. So if she gave you multiple choice and said, what is this? And she didn't have like an element, she didn't say acid or base or anything like that, you would know it is donating a proton. That's how you would know. And it's donating it to the water molecules, which is why it becomes H3O, right? So this behavior is consistent with the definition of an acid as, what is that called? When you donate a proton. What is that called? Does anyone know? Oh, I donated a proton to the water molecules. What is that definition called? Does anyone know? What is that called? When you donate, proton donator versus acceptor. Donor. Okay, this specific, I don't know if Dr. Kelly's going to put this specifically on your exam, but in Chem 1212, they use this as the name. So what is that called? Does anyone remember? I think that's also in your textbook. Proton donor. Okay, and do we all agree with that? Proton donor. Does anyone else have any other answers? Or do you agree? Like, if you agree, you can put like thumbs up or I don't know. Do we all agree? This behavior consistent as just a donor? Yes? No? I don't know? Yes? I just need one more person. I think so. Okay. Yes, that would be correct. It's a proton donor. And because it's a proton donor, water is a what? If that's a proton donor, what's water? That's a proton donor, which means the person who gets the proton is a acceptor. Yes, exactly. Yes, Stephanie. It's a proton acceptor. Correct. So, and what is that the definition of? A proton acceptor. What is that called? When an element accepts a proton, what are they? What's their label? What are they called? And this is just a basic definition. You accept the H, what are you? Or you accept the proton, what is that called? What does that make you? A base. Okay, question mark. Okay, does anyone agree? Ion. Okay, I need one more answer. Someone said base, and then Akash said ion. Does anyone have any other answer? Makes you an ion? Well, there's a lot of things that could be ions, right? Even just elements alone could be considered like ions. So, any other answers? Anyone else? Yes? No? I don't know. Anyone else? Dolores, Connor, anyone? I don't know. Okay, it's actually a base, so Stephanie was correct. When it accepts that proton, that's the base. That's how you would know. And then a proton acceptor is a Bronsted-Lowry what? And this helped a lot if you're taking Chem 1211, by the way. What is that called? Chem 1212. You guys learned that in Chem 1212, by the way. A proton acceptor is what? Does anyone know? What is that called? A Bronsted Lowry. Like, what is that? You don't know? Okay, did you guys? This is so weird because you learned this in Chem 1212. So I don't know why they're teaching you this in Chem 1211 because we didn't do this when I took Chem 1211. So I don't know why they're teaching you this. But like titrations, you guys do those labs in Chem 1212. So I don't know why they're teaching this to you guys now. That makes no sense. But yeah, it's actually an acid. I don't think anyone knows it yet. Because again, I don't know why they're teaching you that. I don't know why they're doing that. And then proton donor is a what? If that's an acid, then this is a what?
A base.
Base, yay! Yes, exactly. That's a base. So now that you guys got that, see, it's pretty easy, right? Simple definitions. What's the neutralization reaction? How would you identify it? Like if she gave you a bunch of equations and she said which one's a neutralization reaction versus oxidation reduction or acid-base reaction, like how would you know it's neutralization? Like how would you sort it out and be like, this one's neutralization and the other ones are oxidation reduction? How would you know? Base. The base. Okay. So reacts with it and produces. Okay, yeah, that's correct. So what is the result? So when you look at this, and you have a neutralization reaction. You guys keep saying base, right? Oh wait, that's the other one. So reaction where the acid reacts with the base, it produces a what? And again, you do use a base and an acid. So when they react, what do they make? How would you know? This is pretty easy. Like once you know it, you got it. Produces a solution of what? What do you produce when you have a salt and water? Okay, anyone else? Okay, so Jorge said salt and water. So do we all agree with that? Or is there another answer? Anyone else? Stephanie, Delores, Kosh, Connor, like do we have any other answers? I don't know. Okay, you don't know? Okay, so yes, Jorge is correct. That's how you know for sure that when you have a neutralization, if it goes like this, and it has like Na, whatever, that's a salt. That's how you know, like, that's neutralization. And then they have water with it. That's dead on a neutralization reaction. That's like how you would know for sure. It produces a salt and it has a water, or it's like produced in a water. That's neutralization. Like, for sure, that's how you would know. And like differentiate it and like a multiple choice problem. That's exactly how you would do it. And then the product of this. What's the product? What's the main products you get from neutralization? Can anyone tell me? Can there be other elements too? Yeah, of course. There's definitely other elements as long as you have a salt. A salt at the end of that. Like there's a production of a salt. That sounds like assault, like when you hit someone, but like assault, right? So as long as you can have other elements, just as long as you put a salt in there as well. Yeah. And then yeah. So what's the product of that? What's the main product you get from a neutralization reaction? Can anyone tell me? Because we just said a salt and an H2O, so what's the obvious answer? Neutralization. How would you differentiate that from oxidation reduction or acid-base reaction? How would we know? Can anyone give me an answer? For sure. Like, how would you know? Does anyone have an answer? Yes? No? I don't know. Here's the, again, attendance link. So if you just came here and you didn't see it, attendance link. Please sign it if you can. So what's the, any, C2. Okay. Yeah, that's partially your answer is correct. It's just a salt, basically, what you need. As long as you know there's a salt in there, like, that's a neutralization for sure. And then what's an overall ionic equation? Or question, whatever. Like, how would you know? Like, if they say, oh, here's a reaction with these two compounds, and it said make an overall ionic equation. How would you make that? Aren't both two contradicting each other? Okay, I understand. It's a thing in Chem 1212, and it makes like in Chem 1212, it does. There's two different definitions. You have the Bronsted-Lowry acid, and then you have the regular acid definition, and they switch. They're like opposite of one another. So maybe you just ignore this right now because it doesn't make sense because you guys are in 1211 right now, but it makes sense when you're in Chem 1212 because it's the opposite. It makes sense if you're in Chem 1212. It's on your like first exam, like you'll see it, but it's basically for right now. Just know like for the Bronsted-Lowry acid, Bronsted-Lowry base, know that, but then know the regular definitions of acid and bases because I know they're basically opposite of each other. But that's it. That's all you have to know. So did you get that, Jorge? It's weird because you're not in Chem 1212 yet, but that's how they teach it. It's like you have two different definitions of each. Is that okay? Do we understand that? Yes? No? Jorge, are you okay? Yes? Are you still with us? Yes, no, I don't. Okay. Yes, hello? Yes, no? Because now you're confusing me. Are you alright? Yes, okay, great. So, overall ionic equation. Just in case you guys didn't know already, with an overall ionic equation, I'm just gonna say it. It's a balanced equation that basically just shows the ionic and molecular species. So it's just like a regular balanced equation pretty much, as long as it shows both elements are just ionic and molecular, which is just, again, the regular equation, right? So once you do that, you go to, and this is the answers for that. You go with the overall, let me split them with the protein. Oh no, that's the net ionic, where you cut out the spectator ions. And I'll get to that in a second. Yeah, so net ionic equation, pH on this unit. pH, you do that more in like Chem 1212. I'm not sure you guys do this in your unit, but they're doing Chem 1211 very differently this year. Like Chem 1212 has titrations, but Chem 1211 wasn't supposed to, but you guys are doing titrations. So that's what makes me kind of weird. Like why are Chem 1211 students doing titrations? That doesn't make sense. Because they're doing that right now in Chem 1212. So I don't know why they're teaching it so weirdly. Like I don't know. But pH, if not this unit, definitely Chem 1212. For right now, as of right now, not really. I don't really notice it. Do you guys, the rest of you guys, do you guys see pH a lot? I don't see pH a lot. I don't think you need it very much. I don't remember doing pH in Chem 1212. I mean 1211 right now. So I wouldn't worry about it as of right now. So net ionic equation. So balanced equation that eliminates what ions? What ions do you eliminate in a balanced equation? That's different from the other equation. What do we do? Why are we eliminating? Does anyone know? Yes, no. So you have the net ionic, the spectator. I think you're trying to say spectator ions. Okay, yes, correct. Spectator ions. Yeah, spec. I'm just gonna say spec for right now because it's easier to type on the computer. Spectator ions. And basically, if you don't know what spectator ions are, it's pretty much when you if you take your balanced equation from the overall ionic equation and you separate all the elements out, whatever on the reactants and product side is the same, you cross them out. And those are considered spectator ions because you don't need those, right? They're just spectators. That's why it's called spectator ions because you don't need it. They're not the real players of the game. That's why they're spectators. And you cross them out, and then your final equation will be the whole equation without those spectators ions because you eliminated them. And you knew that from the what? What are you crossing out from the original? Spectator ions from what? Does anyone know? We just talked about it actually. So what do we cross it out from? Can anyone tell me what that is? Yes, no, I don't know. What is that? Can anyone tell me? What is that? You cross out and you have all these elements and you go to the other side and let's say these two are the same, so you cross it out. And what does that come from? Like from above? What is this called? That little thing from above, what is that? It's called a molecular equation. I'm just gonna say it. Molecular equation, but it's also called the overall ionic equation. Remember, we just spoke about that last slide. This is like probably like the hardest unit in my opinion. So if you're confused, please let me know. Ask a question. I don't mind. So like Jorge had a question, like Stephanie and stuff, or like Dolores. So if you have any questions, don't hesitate to ask me. So yeah, we have the molecular equation or overall ionic equation. So a strong acid completely what? What do we do with a strong acid? It completely blank. What does it do? Can anyone tell me? Dissolves, okay. And then do we all agree with that? Jorge said dissolves. A strong acid completely, yes. Yes, that's correct. Yes, strong acids completely dissolve. And then weak acids, as you can imagine, they don't completely dissolve. Some of them don't even at all. And then it will be kind of like a non-electrolyte at that point. So I even put the answer for here, so I can't even do that one. But it's just a spectator, unchanged element in a reaction. And then acid that can donate 2 protons per molecule is a, what? What is that called? Does anyone know what that's called? Di something. Okay, you're on the right track. So does anyone know the other half, the something part? What is that? Di. Does anyone remember what is that called? Di. Any guesses? Di. Acid. Something acid. Di, right? So di what? Any guesses? If you don't know, you can just write I don't know. I just want to get you guys, okay. I just want to get you guys used to like vocabulary. So you see this word, you're not going to be like, I don't know what that is. Diprotic. It's just a fancy word to be like, oh, it just means instead of like one H over to the other side, it's two of them. So it's two H plus. And you can even do it for three. So you can do triprotic as well. It's not just di. It can be tri as well. And then a weak acid, what? What does a weak acid do? Because strong acid completely dissolves, right? Or ionizes is a better word. So what does a weak acid do? Does anyone know? A weak acid, because if a strong acid completely ionizes or like dissolves, like you guys said, what does a weak acid do? Does it not dissolve at all? Does it? What does it do? Partially. Yes, correct. Partially dissolve or partially ionizes. Yes, I'm just gonna put a P and then I. Partially ionize, partially dissolve. Either definition works. And so, by the way, if it doesn't ionize or doesn't dissolve at all, that's just basically a non-electrolyte, as we went over. So that's how you would differentiate. So are we good on this slide? Yes? Yes? Yes, okay, great. Okay. And that's the answers. As you can see, I kept the same answer on the other side like an idiot. But yeah. Okay, yay. So now it's time to write some equations. Write a balanced molecular, ionic, overall ionic, and then net ionic equation that describes the reaction that takes place when an aqueous solution of nitric acid is neutralized by an solution of calcium hydroxide. So what do we do first? Can anyone tell me what nitric acid, like what's the formula for that? Does anyone know nitric acid? Yes, no. If you don't know, I'll just write it down. Okay, it's fine. And let's see. Yeah, kind of, yes. Mm-hmm. So, and then calcium hydroxide, does anyone know? As long as you get the elements right, I'll be pretty happy with that. Calcium hydroxide, can anyone tell me what that'd be? Yes, okay, so I'm kind of just happy you guys got the elements right. The other parts, like the subscripts are wrong, but that's okay. So for this, it's just NO3. Yep, yeah, the subscript. But it's fine, as long as you got like the main elements, I'm not too angry or like, sad about that. So Ca, and then you have OH, and then Jorge's right, the subscript is 2. And then it goes to the reaction. And does anyone know what that goes to? Yeah, so what does it transfer into? What's the other product side? What do you get when you put HNO3 and CaOH2? What's the first product you'll have? Can anyone tell me? What is that going to be? What's our products going to look like? HNO3 plus CaOH2. It's H2O. You don't know. Okay, as long as you have a good guess or you want to make an assumption, that's fine. So H2O, NaCl, or H3O, ACl. Okay. Alright, so actually, what we're going to do is actually going to take, because you want to make an ionic, right? You're going to take this, the Ca, and you're actually going to put it together with the second element of the first, because you're just trying to make 2 products from this. And the only 2 products you can really make, yes, Jorge is correct. And yeah, the H2O is correct, by the way, but I'm starting with CH because I think it's easier to explain that way. The subscript, it's just like calcium hydroxide. It's just like a basic compound formula of that. Pretty much, like, you're not naming them or like making formulas from this. That was last unit, so I wouldn't worry too much about it because this unit is just making the equations in general, like thing in between. So it's gonna be CaNO3, right? So you got that, and then you have 2 on the other side, and then plus we have H2O. So now that we have that, what do we do next? So now we have our equations. What do we do? Can anyone tell me? What do we do with this information? Does anyone know? So we have our equation, but what's wrong with it? Balance it. Yes, exactly. And I'm just going to balance it for you guys because I think we're low on time. But you guys know how to balance. Like, that was the last exam, so I'm not going to force you guys to balance this because you guys know how to, like, count and multiply. You're not 8 years old. So 2 on that side, and the other side is 2 on H2O. So now that's balanced, what do we do next? So now you have your molecular formula. We did A, so A is complete. Split ionic compound. Yes, exactly. So what are we going to get? What is split up exactly? Which elements? Right? So which ones do we split up? And like split them up for me. Like how do we do that? What does it look like? Right? NO3. Yes, correct. So one of them does end up being NO3, and we have 2 on that side, right? We have 2 NO3, and then do we have anything else? So we have 2 NO3. What's the other part? Could you split up HNO3? So what's the other part have to be on the other side? 2 NO3 and what else? Can anyone tell me? Yes, exactly. 2 H plus, right? Because you split up HNO3. So that has to go. And so those 2 are together. What else? What else do we have? Can anyone tell me what else do you split up? What's the next thing? Right, because we still have CaOH2 and then CaNO3 too. So what goes next? What do we split up? What's the next element that comes from this? Does anyone know? It's just right there, the next compound, right? So what's the next thing? Does anyone know? If you don't know, you're I don't know. Yes, no. See, yes, exactly, correct. So now we have 2 C. Hey, that's 2. Let's make that a little clearer. Yes, and then, so what's the next thing? We have one more, right? So now we have Ca. So what's the next one? Can anyone write that for me? What is that? Is it gonna be H2O as a whole, or what do we have? Can anyone write an answer? Does anyone know? Or you can use your mic. No, that's always an option. Let's not forget the mic. Does anyone know? So Ca2, and then what else? Oh wait, yes, exactly. Thank you, Jorge. It's very nice of you. Okay, so now that we have 2 OH, and then the next, I'm just gonna do this next one because I just think it's easy. And it's basically a copycat of what we just did, so I'm not gonna like force you guys to do that. Then we have 2 NO3. I'm just breaking up the second products, by the way, if you're confused. And then H2O, you just keep as it is. Usually, if you see H2O, you usually just keep it as H2O. You rarely ever like break it apart. Like you don't need to do that. So it just stays as H2O. So now that we have that, what do we do? What do we do next? What's the next step? So now we have our net ionic equation. We did B. Finished. Done. Now we have to find the net ionic. So what's the next step? How do we cross out? Cross out what? What are we crossing out? Can you tell me what we're crossing out? Because I'm sure everyone knows this, right? What are we crossing out? Spectator. Yes, Savannah, you're completely correct. Spectator ions, yes. So which ones are spectator ions? Yeah, like ions. Yep, that's correct. So which ones are we crossing out then? Which ones? Can anyone say what that is? Can anyone tell me? What is that? Ca. Yes, exactly. Ca, because it's on the same, right? So we cross that out. What else needs to be crossed out? Or is that it? NO3. Yes, exactly. 2. Yep, because same things, right? So now when you finish, you have 2 H plus. Thank you for answering, by the way. Very nice, very sweet. So OH. I get really happy when you guys do that. So thank you for participating. And then 2 H2O. So that's it. If you want to simplify it, you can always do that because they all have 2's, but then you would just basically like do that. So it's basically the same answer. H plus OH minus or negative, and the product is just H2O. And then you finish C. And then there you go. So is that good? This is basically acid-base reactions and how you would do that, right? So please be familiar when they ask molecular, you know what that is. Ionic, you know what that is. And then ionic, net ionic is usually the final result. On tests, they usually just ask for C. They don't really ask for A and B. They just say like, what's C? Or if they don't, they just say, what's the spectator ions? They ask those questions a lot from what I remember. So, but molecular, you don't really have to care about. Just know spectator ions and the net ionic equations for sure. Like how to get to the final product and what you cross out. Are we good on this? Yes? Pretty simple, it's only 3 steps. So yes, great. Okay, thank you, Savannah. Okay, and that's the answer. Just in case you were like, I don't get it. This is like, I guess, a clearer version than what I was writing. Yeah, but if you have any questions about these, please let me know. Yeah. And then here's another one. So write a balanced equation for, it's the same thing basically, but we're gonna go faster, right? Because we know this. So what about phosphoric acid? And look, they even gave it to you. How nice. And then sodium hydroxide. I'm gonna write that one because it's easy. NaOH, right? Then we have, and they're so nice because they gave it to you so you don't have to like figure it out. So pH 4, and then you add those, and then that creates sodium. So we have water, right? So pretty easy. Go ahead and create water, which means you're not going to break it apart because usually when you have water, you don't need to. So Na3PO4. So what do we do? So now this is molecular. I just gave that one because they pretty much gave it to you. They just wrote what it is. Molecular, you're just writing it out. Reactants and products. Pretty easy. So what do we do next? Can anyone tell me? What do we do? Now that we have the molecular equation, how do we do overall ionic? What's the next step? Can anyone tell me? Yes? No? I don't know. Any answer is fine. Any answer is acceptable. I don't want anyone to think, oh, I have a dumb answer. Balance. Yes, Savannah, yes. So I'm just going to balance that for you guys just because you guys know how to do this. That was last exam, done and over with. So 3 and 3, and that's, again, that's pretty much balanced, pretty easy. So once you have it balanced, what do we do next? What do we do once we have this? Does anyone know the next step? And I know you guys know how to do this. I just reiterate it because the more practice you have, the faster you go. And when you do the test, you go faster. So you don't have to waste time on easy problems that you would know. So what do you do after this? You balanced it, you have molecular, now you need ionic. So what do you do? I think Jorge said this before, the next step, which is here. So what is that? Does anyone recall what that is?
Split
You
it?
what? What do we do? This is A, right? How do we get to B? Split it. Yes, exactly. So what are we splitting here? And can someone split it out? Split ionic, yes. So what are we splitting here? What are we going to split specifically? What compound are we splitting? Can anyone name it? There's only 4, so you have like a 25% chance of getting this question right. What are we splitting here? H3PO4. Okay. Do we have any other answers? Do we agree? H3PO4? Yes, no, I don't know. Do we agree? Yes, no? Or is there another answer? Anyone else? If you have something you want to say. Do we agree? Yes? Yes, no, I don't know. I'm guessing. Okay, so we can. Let's split that up. So we have H, right? I'm just gonna split up like that, just the elements alone, because I think it's easier to do. So that, and then are we gonna split up NaOH? Yes or no? Yes? No? I don't know. What is it? Are we gonna split that up? Or are we just gonna keep it? Yes, yes, exactly. So now we have Na. Again, I'm not putting the like coefficients just because I don't. It's whatever. You're looking at the elements specifically. So I want you guys to focus on that part. And then now we have water. Are we gonna split up water? Yes or no? Can anyone tell me? Are we gonna split up
No.
HO2? And yeah, H2O. H2O. Sorry, I don't know why I said that. No. Okay, do you agree with that? Because there's a question mark at the end of that. So, do we agree? Is it no? Is it no or yes? Are we gonna split up? Agree. Yes, exactly. You don't split it up. most of the time you don't split up water. You don't need to. And you split it up. It's just H and then like you don't need to. So we're just gonna keep that as that. And then Na3PH4. So are we gonna split that up or not? Yes or no?
Yes.
Are we gonna split that? Yes. Yes, exactly. So it's gonna be Na and then PO4. So what's our spectator atoms? Ions, sorry. Spectator ions. What are we crossing out? NaPO4. Yes, exactly. You can cross out this, right? And then PO4. Wow, look how fast and easy that was. So the thing is, okay, so you guys keep saying PO4, but the thing is that that's why when I said Dolores, like, are you sure it's that? Because you actually won't cross that out. And that's what I was hoping someone was gonna say, but then no one said it. So actually, you're not gonna cross this out. This stays together as HPO4. That's why I said, are you guys gonna separate that? You don't. You don't cross it out. It stays just as it is. You don't cross out the other stuff. It's just this stays together. Wait, why not? There's some elements, like especially like this, where you just don't need to. You don't have to, and you don't need to, and it's unnecessary to do so. So you actually end up keeping it. And I'm not sure how grave an explanation that is. It's probably really bad, but like, I don't know how to explain. It's just some of them you don't need to, and it's unnecessary to do so. One of those exceptions? Possibly. Like, this question's kind of weird, just because I think if Dr. Kelly gave you a question like this, she would make it as to where you could cross it out and do all this stuff, but for this one, you don't. And I know this one's very weird. It's from the textbook. Is it the soluble rule? It probably is. Again, like these questions are kind of weird because if you like this unit, you don't learn solubility rules until the next section. So this is why I don't like this part of the equation, because you haven't learned solubility rules until the next section. That's why this one doesn't make sense yet. But I just want to let you guys know that sometimes that there are exceptions. Yeah, there's exceptions like this where you don't cross it out. You keep it as is. And then when you have it finished, it's just you keep OH and it goes to H2O. And then the PO, here I'll write it over here because it's easier. PO4. So does that make some sense? If not, do you guys want to have this PowerPoint? Like, do you want me to send it to you? Yes or no? If you don't need it, that's fine. I just want to see if you guys need it or not. Yes, please. Okay. If you write yes, I'll send it to you. If you don't, I just won't. But yeah, so if you need it, just write something in the chat and I'll look at it and I'll send it to you. And I'll probably put an explanation for this question specifically, like why you would keep it. And it does tie back to solubility. So yeah. It's a weak acid. Yeah. So again, like this question, they don't do a great job of explaining because they didn't put into account the other stuff in it. The way the explanation that they give for this is, it doesn't make sense unless you've read the rest of the chapter. Like they only do one part and they're like, solve this question. But then they don't give you the rest of the information that will make the whole question make sense. So I'll probably add an explanation to this one as well. Okay, are we good on this one? But the rest of it you understand, right? The crossing out of the NA and stuff, you guys understand? That's the main part I want you guys to know. Yes? We're good? Okay, good, great, okay. And that's the answer. And as you can see, this still does stay together, and PO4 is still there. And the only thing you cross out was just this. And then everything else stays. So again, very weird. But there's always exceptions like this. So yeah, I just want to give you guys like every aspect of what it could be instead of just easy questions. Because I saw a lot of people in like group me's and like online classes say, our teacher gives and during class the questions are too easy, or then the test the questions are too hard, and then they don't go over. It doesn't match. So I wanted to give like harder questions on here instead of like easy ones, because I want to make you guys more prepared, like have you guys come in with a better sense of what you're getting on the exam than just cutesy little concept questions that everyone knows. Like balance this equation. Like everyone knows how to do that part, you know? So yeah, okay. And then this is a concept test. So identify each of the following compounds in an aqueous solution as either as an acid, a base, or neither. So you're basically identifying it acid or base, and is it weak or strong? So now we have B, C, and D. So A, CH3, CH2, COOH. Is that an acid, base, and is it weak or strong? Can anyone tell me? What is that going to be? Does anyone know? Yes, no, I don't know. You don't know? Okay, does anyone else have an answer? Like, what would that be? Base? Okay. Alright. So, okay, with this, I think is that, okay, do we have any other answers before I explain? Any other final thoughts, answers? If you know it, please let us know. You can help out your other classmates, and you don't know. Okay. So for this, there's, again, I hate that they teach you this in Chem 1211, but there's a set of strong acids, strong bases, and the reason you would know whether it's an acid or a base is usually because of the way it's written. There's a list. And I'm going to show you guys the list really. Here, let me show you the list first. This is in your textbook, and it's very, very helpful. So as you can see, you have all this stuff, right? Like, this is a strong acid, and then you have like your weak ones, right? And they give you the equations like HF, CH3O, COOH. That should ring a bell. So when you look at this, you would know. So if you memorize, I'm not saying you have to memorize all these, but that's what I did. But again, it's up to you and what you want to do. So when you look at this, we had CH2, CH3, COOH. When you see these charts, what is it going to be? Can anyone give me an answer? The answer is kind of like in your face, but like, can anyone tell me? Is it going to be acid or base? And if it is, weak or strong? Does anyone know? Yes, no, I don't know. Can I get an answer? Does anyone know? Strong acid. Okay, so we have strong acid. Any other answers? Strong acid. Okay. Anyone else? Someone says strong acid. Akash says strong acid. Do we have anyone else? Like, we agree, disagree? Or you just don't know? You still don't know? If you don't know, you just write, I don't know. I'm not like a teacher. I'm not gonna like prosecute you or anything. So, any other answers? You don't know? Okay. So as you guys can see right here, it has acetic acid in it almost. CH3, COOH. That's a weak acid. And the other part was CH2, right? And as we know, that's nonpolar. Again, like, it does nothing. So it's actually a weak acid. It's not as strong, because look, strong, where is that? Where's the CH3COOH? It's not there, right? It's not a strong acid, which means it's a weak acid. This is especially part of it, right? So when you look on here, CH3, CH2, COOH, that's a weak acid. Do we understand that? Again, if you look at the list, it had it completely on there. This part, right? So that's how you would know. Do you understand that part? Again, the charts make it a lot easier to understand because it has acetic acid, and that's a weak acid. So we understand that part. Reverse the chart. It's up to you if you want to. I personally do because it's easier to know, like common strong acids, common weak acids. Just in case if she asks, oh, is this a strong or weak acid or base? And then you would know. Like if it had like NO3 or something, you would be like, oh, that's obviously a strong acid or strong base or whatever. Like you just know, right? Because you memorize all the strong acids. So it's up to you. Depends on what you want. No, without the chart. Maybe, honestly, I haven't learned anything of that sort. Usually strong, like, there's no, like, pattern to it, if I'm being honest. There's no, like, oh, you would know because there's this little trick and pattern, whatever. Again, it's only, like, 1, 2, 3, 4, 5, 6. It's only 6 over here, and then, like, 5 on this side. 1, 2, 3, 4, yeah, exactly. So it's just, like, 11 things. It's not too bad. But, yeah, I don't really know any tricks personally. Sorry about that, but let's keep going. CH3OH. What is that going to be? Or a base? Can anyone tell me? What is that going to be? Does anyone know? Do you have a guess? Weak acid. Okay, weak. Any other answers? Weak. Weak, okay. Anyone else? You don't. Okay, weak. Actually, this might surprise you, but it's actually neither an acid nor a base. It's a trick question. Yeah, this concept test is weird. Acid, no, not an acid or a base. It's neither one. It's nothing really. It's just a compound in there. They basically put that in there to trick you with the A. So it looks very similar. So you would think, oh, it's a weak acid. No, it's nothing. Like if you look at this chart, like there's this not none of it's on here. Like where do you see that? Exactly. It can't be strong, so you would think, oh, maybe it's weak. But if you look on the weak side, there's nothing on there. So it's not a weak acid. Weak. It's nothing. It's not even a base because bases you would know because they have OH in them usually, and that's how you recognize a base. But with that one, again, like exceptions, it's not really anything. There's nothing in this one. Again, with the CH too, like it's neither one. So now that we have that, what about C? MgOH2. Capitalize on the OH. And we know this is an ion specifically because it's put with those parentheses. So is that weak or strong? Or is it an acid or a base? Base. Yes, correct. Pretty easy, right? Too. So you'd be like, oh yeah, that's definitely. Is that strong or weak? Do we know? Yes or no? Weak. Yes, exactly. That's a weak base. My bad. Yeah, and you can tell with the OH as well. So yeah, that's how you would know. And then what about D? HNO3. Is that weak or strong acid or base? What are we looking at here? Strong acid, strong acid. Okay, and do we agree with that? Strong acid? Yes? Do we all agree? Anyone else? Any other answers? Yes, no, I don't know. HNO3. I just need one more person to agree. Okay, great. Okay, so, yep, that's right. It's a strong acid. And these are basically the answers. Again, so, base. Again, that's what I want to talk about, is that sometimes there are exceptions, but usually if it's OH like that, especially in the way that this is put, a lot of times it can be seen as just a base, right? Because when you learn about bases and acids, don't you guys see like OH as a base, usually? Yes? You guys know that, right? Like OH, a lot of times it's seen as like a base, right? Did you guys learn that? Yeah, exactly. You guys learned that. So that's how you would know. But then there, again, exceptions like V. So it's great to know that like there's exceptions to things. It's not all cookie cutter, yes or no, black and white. And I hate like practice problems where they only show the cookie cutter black and white. And so when you take the exam, they have that gray area and then you don't know, right? And then you're all confused and you're like, oh, I didn't learn this. B is neither. It's just, you can just tell when you look at it. I don't know how to explain it. Maybe when I send this out, I'll do another explanation. Because I don't know how to explain it into words right now or like write it in a sentence. You would just know, like, you can just tell. But that scene has OH, so I was confused. CH3OH. Yeah, that's what makes it, again, like exceptions. But it's good to know now that there's exceptions than like on the test when you're like, oh, well, I didn't know there was like an exception, and then you get it wrong, you know? But at least now you know CO3OH is definitely non-acid or a base, right? So if you ever see that on a test, you're like, I know that's a trick question. You can't trick me. So yeah. And then this, again, like these charts are helpful. It's good to know. I would suggest memorizing